And so next we're going to talk about these tipping points as a conceptual model to help you understand another facet of nonlinearity. And in this at this time, I would like to ask you to pause the video for 5 minutes and go play this 5 minute demo through, and you will see these red elements in the interactive sliders. So try to move all of those. And so there's the English version. If you scroll down, you will also find a Finnish version that me and Kaisa Saurio translated with the help of many others. And yeah, so not everyone will like doing this. Some people will like it very much, others may not. But this is also one of those things that I have personally found very helpful to do many times over and over again over the years. So even though if I've done it 6 months ago, if I do it now, it might give me new insights. So that's why I'm really fond of it. So please go ahead and pause the video and go play this now. Okay, so thanks. So now we have some understanding about a basic understanding of what attractor landscapes are. But we will, don't worry, we will talk about them some more. So first of all, if you have a look at the bottom of the screen, there's a reference for a paper. In that paper, we talk about these attractor landscapes in very concrete terms and give tons of examples. So, and also there's a table with complex systems features explained via this topic of attractor landscapes. So feel free to check it out. But the basic idea is that we have this sort of a landscape, and the form of the landscape sort of depends on everything that's going on. So if you remember, we had this the network that was depicting the 14 facets of the theoretical domains framework. And so all of those patterns would sort of create this dynamic on the micro level that would then create this attractor landscape that uh, uh, would allow or repel some behaviors or some states of the system on the macro level. So the landscape is an emergent feature of the micro level interactions. But the thing to know about this is that if you have two attractors and for example, if you're in a situation where switching state from A to B is not as easy as switching state from B to A. So for example, if you're smoking and quitting smoking is more difficult than starting smoking after you quit, then you're in a situation that depicts hysteresis. And hysteresis doesn't happen in linear systems. So this tells you that you're in a nonlinear situation and you should really reconsider whether you want to use linear methods and these regression analysis and correlations and all of that kind of stuff. But so another point is, of course, that the attractor landscape in complex systems, it's a complex context. It's shifting constantly. So, well, it might shift slower or it might shift faster, and you might want to have an idea about what is the dynamic that's and how stable is the phenomenon that you're dealing with. But one important point is that if you are in a situation like this, it's much easier to uh, so for the system to change position in this situation is much harder than in this situation, where because the system is constantly being bombarded with different um, random fluctuations and events, maybe even fat-tailed events that will kick you out of a very deep attractor. But if the attractor landscape starts becoming shallower, it becomes more easy for the system to change state. And this is also something if you're trying to make a change, create some change in your community or something like this, or improve people's well-being, and nothing seems to happen. It might be that like behind the scenes, sort of in the underlying the landscape that you can't directly necessarily observe, and that the current attractor is losing its resilience, as we call it. So this is this is a more resilient attractor than this one. And resilience in this context means how much does it take to push the system to a new state. And then if the system changes to uh, like this much, then you would be in a in a situation where you could actually very easily push the system to the other attractor. And this is also, if you look it up, our group in the Prime Minister's office, we have produced a working paper with the Center of Excellence for Countering Hybrid Threats, so hybrid COE, where we talk about this model and how the destabilization of society can be conceived via this model. So when you have these hostile actors who want to do destabilization and then use different tools to move the society to a state of disorder, for it. And yeah, so the tipping points can take two forms, or not tipping, but tipping phenomena or critical uh, uh, transitions. So you have uh, on the left, you have sort of bifurcation induced tipping. So this changing of the landscape is called bifurcation. And on the right, you see the N tipping, so noise induced tipping. And so there you have the works also. And there's also a thought by Daniel Proverbio, who was co-authoring with me in the aforementioned paper. And so we had a symposium where we brought together policymakers and people dealing with humans from different fields, and try to think about, okay, so what would be good um, things to bring from complexity science to the public policy. But yeah, you can have a look at the video from that blog post.